Okay, page 199. You were supposed to do number 39. So page 139. Turn down your music. Number 39. There it is. Okay. T. The equation for the cost in dollars of producing computer chips is C equals 0.00. Uh-oh, way too many zeros. 0.0000. No, there's 4. After the decimal. 1 5 x squared minus 0.03 x. I don't need it in front. My eyesight's bad enough. Plus 35. I don't know. Well, no, it started doing it all of a sudden. It's got to be one of the wires. I'm gonna try just hooking up the VGA, but I'll try it next hour. Well, it's gonna be a major project. Okay, where X is the number of chips produced, find the number of chips that minimizes the cost. What is the cost for the number of chips? Okay, so we have to minimize the cost. Let's put this in the calculator and let's find the vertex. Okay. So you got your calculators. You guys have this problem done, right? That's what the word homework means. All right, here we go. I'm glad that's on video. 0.000015 x squared minus 0.03 x plus 35. A graph, and nothing shows. You know why? Because these are, our window's messed up here. First of all, these are really small numbers, and then we have initial height of 35. So our initial height can be at least 35. So we need our y minimum at 35. So let's put in our y minimum. Here, let's put in 40. Let's see what happens. Wow. Oh, by the way, this is a fraction, right? This is a fraction between 0 and 1. It's not just any old fraction. It's a really small fraction, right? I mean, really small. So this parabola is going to be hugely wide, okay? So we need to try to get that in our screen. Let's see. We're gonna make this. If it's hugely wide, we're gonna make some huge numbers on our x-axis. Okay. So let's go back to our window. Here's my x min. I'm gonna make this 100, and our x max. I'm gonna make 100. Now graph it. See what happens. Not even. Well, we're not even close here. It's still going down, isn't it? Let's try 1,000 max. Then see what happens. Oop, oop, oh, we almost got it. Let's try 2,000. Yeah, or no. Yeah, why not? Let's go for it. 10,000. Does it work? Look at that. We need to find our minimum cost because we have a minimum point, right? So let's go to second trace. This time we're going to look for the minimum, 3, hit enter. My X right now is at 5,000. Bring it down, bring it down, bring it down, cursor. Oh, 10,000 is way too big. So let's bring it down to 2,000. Keep doing it. Okay, left bound. Get to the left of our vertex. Hit enter. Get to the right of our vertex. Hit enter. And hit enter again. And our vertex is, we're going to round this, 1,000, 20. Okay, so what's our minimum cost? See, this is the y-axis. So what's our minimum cost? 20, right? That wasn't so hard. Yeah, these aren't easy problems. Okay, what was your next assignment? Number page 207, number 38. 207, number 38. I'm sorry for the blurriness. Okay, it says, I think I gave you a hint on this one. Area equals length times width, right? This is page 207, number 38. It says a town is planning a playground, wants to fence in a rectangular space using an existing wall. What is the greatest area it can fence using 100 feet of donated fencing? I'm thinking they're trying to tell you what's length times width. They're asking you. So I got this rectangle. It's a rectangle. And the dimensions, picture tells us it's length and our width 100 minus 2L. Okay. We know that the area formula equals length times width. And we know that we only have 100 feet of fencing. So that's got to be our area. Our length, which is just L, times our width, which is 100 minus 2L. Now all we have to do is solve for L. All right, I'm going to distribute. Alzheimer's kicking in. 100 equals 100 L minus 2L squared. Got to get a 0 on one side. So I'm going to subtract 100. Subtract 100. So I get 0 equals, let's see, I'm going to put this in standard form. So I'm going to put my minus 2L squared plus 100L minus 100. Now I have a quadratic equation, right? I can put this into my graph. Ready? I'm going to put my window back to standard. Zoom number 6, standard window. Put in my equation, negative 2L squared plus 100 L minus 100. Now this is going to be pretty big parabola too, right? Graph it. Yeah, we only get one line. So let's see, our initial height here is 100, right? So might as well start there first. Let's go to our window. Bless you. You're welcome. I don't know. I'm going to put this at 200, see what happens. Why? And in my x-axis, oh, bless you. Wow. My x-axis, I'm going to put it way out here. My x-axis, I'm going to put that at 200. Oh, that was pretty cool. I don't need quite 200, maybe back it off to 100. You put the y at 2000? Y max, try 500, 1000. Okay, I think we're ready. Oop, a little more on the y-axis, huh? Try 1500. There we go. Okay. So we're looking for the L. So we're looking for the intercepts, right? Let me get some negative numbers down here. Back to my window. Y minimum, and I'll put that at 100. I just want to go down. See? Okay, so I need these two intercepts, right? Intercepts. See, second trace, 0, enter. We can, since my cursor's over here, I'm going to pick up this 0 first. Left bound, enter. Right bound, enter, enter. So that's at 49. When you take a note here, notice it says my y. Remember, my y value at the intercept, x-intercept is 0, right? But I get this goofy thing here. It's y equals 1e to the minus 10. That's a pixel thing in your calculator. Okay, it just can't get to 0. This means that this is scientific notation for 0.1 times 10 to the negative 10. It's 0. Okay. Let's go back and pick up the other 0. Make sure it's not negative. So second trace, 0. This time I got to get to the left of this point. So I'm going to have to be under the axis. Hit enter. Get to the right of that point. Hit enter. Then hit enter again. And our L could equal 1. So we have two values here of what L can equal. Okay. So I could have a rectangle that, let's see if we use 1. See, our L equals 1. Our W is going to equal 100 minus 2 times 1, which equals 98. And I bet you if we put in 49, we're going to get the numbers 1 and 98. C, 49, W equal 100. 49 times 2 is 98, and we get our. So either a rectangle is going to go this way, or you could put the rectangle that way. Was that fun? You guys enjoy that? I don't hear any comment. Told you these were kind of hard. And the last one, 43. I think it's the last one. No, we got to do 50 now. Okay, so 43. 43 says the height of a projectile fired straight up in the air with an initial velocity of 64 feet per second is h equals 64t minus negative 16t squared, where h is the height in feet and t is the time in seconds. We know that. The table represents data for another projectile. Which projectile goes higher? Now, think about this. Which projectile goes higher? What tells us the height of a projectile, the maximum height? It's the y coordinate of the vertex, right? Y coordinate of the vertex gives us the height. So we have a parabola here, because that's t squared. And actually, this is a parabola also, the chart. How do I know that? Because the y values start repeating after this point. Okay, this is actually the vertex. So, what's the vertex? Oh, we need the vertex of this parabola, right? Let's put that one in. Sure. So 43, we need to compare heights of the projectiles. We already know that the height of the table height is 36. The vertex is 1.5, 36. Okay. Now we have to find the vertex of, what is it, h equals negative 16t squared plus 64t. So we need to find the vertex. And to do that, we need to graph the parabola. I'm going to go back to my standard graph. I'm going to put in negative 16t t squared plus 64t, hit graph, and I'm going to go to our chart to see if I can pick up the numbers from my chart, my vertex. Looking for those repeating y values. And I can't, okay? I have 148, 264, 348. There's my 0, 0, 4, 0. So my vertex is 264. Okay, which one's higher? Yeah, this one's higher, right? Is there a name or difference? What are they calling it? Nope. I'll just call this projectile 1. And I'll call this one projectile 2. So projectile 1 is higher by, they want to know by how many feet. All I have to do is take 64 minus 36, and I get 28. 28 feet. That wasn't too bad. And what else? Go. See, page 231. I'm going to do it on the back or another sheet of paper. Page 231, number 59. Okay, page 231, number 59. When serving in tennis, a player tosses a tennis ball vertically in the air. The height h of the ball after t seconds is given by the quadratic function. H of t equals negative 5t squared plus 7t meters. How high in the air does the ball go? So we need to find vertex of this parabola for A. And then B, assume that the player hits the ball on its way down when it's 0.6 meters above the point of toss. For how many seconds? So we're trying to find seconds again. So B, we need to find the x-intercept for time. Now, we do have to deal with that 0.6 meters above the intercept. Okay, so we'll have to deal with that when we get to it. So A, find the vertex. Well, we know how to do that easily. We've been doing this for quite a while now. Let's say I've got negative 5t squared plus 7t. Graph it. And lo and behold, it fits on our screen. I don't have to mess with the window. Okay, so I'm going to have to calculate the vertex. Second trace to calculate. The vertex happens to be a maximum. And am I to the left of the vertex? Hit enter. Am I to the right of the vertex? Hit enter. Enter again. And I get 0.7, comma, 245. So what's the maximum height? 2.45 meters, right? Okay, B. What's the x-intercept? Again, I'm going to calculate the x-intercept. Second trace, calculate the 0. Enter. Am I to the left? Enter. to the right, enter, enter again, and I get 1.4 comma 0. 1.4 comma 0. That's my x-intercept. Okay. Right now I'm at 1.4 seconds. However, that's when my y is 0. I need to be where my y is 0.6. So if I have a graph, let's see what they're looking for. Here's a graph, and I'm going to kind of blow up this parabola. So we can understand what's going on here. So this point right there, that's my x-intercept at 1.4 comma 0. Now, I need a point that is 0.6 higher. So I need this point. Now, look at that distance there on my parabola. Is my time getting smaller or bigger? It's getting smaller, isn't it? So I'm going to have to take my 1.4 and subtract 0.6, the height, to give me that smaller time, which equals 0.8 seconds. So for answer B, 0.8 seconds. Got it? Now, I gave you a new sheet of problem, a new worksheet. This is how your quiz later this week is it's gonna break it down this way. They're not gonna be just straight problems where you have to set them up. They're gonna be pretty much set up for you. And this is like we did on your note sheet. Okay? So you should work through these. Hopefully you took good notes. And we'll go over these tomorrow. Sound like a plan? Thank you for your much needed attention today.